Hey guys, Mr. Backward here. In this video we're going to look at solving rational equations. In this first example we're going to look at something called clearing fractions. So we're dealing with a rational equation, meaning that we're going to have a fraction in there somewhere. So in this first example let's look at x plus 3 over x equals 4. Now, clearing fractions means that we're going to try to get rid of the fractions within this equation. So notice on this 3 over x, we have a fraction where we are dividing by x. So we want to think about how can we get rid of division by x. And in order to get rid of division, we're going to have to do a little multiplying. So what I'm going to do is I'm going to take this entire equation and I'm going to multiply by x. Now I'm going to have to do distributive property. X times x is x squared. When I take the x times the 3 divided by x, the times x and the divided by x are going to cancel each other out. So then all we're going to have left over is plus 3. But then I also have to take the x and multiply it by the 4 on the right hand side. So we would get equals 4x. Now what we can do with this is I can subtract this 4x over to the left hand side. So I get x squared minus 4x plus 3 equals 0. And then with this quadratic, we've got a lot of different options. This one is factorable. I can factor this into x minus 3 and x minus 1 equals 0. After we get it factored, we want to take each factor and set it equal to 0. So x minus 3 equals 0 and x minus 1 equals 0. So I would get answers at x equals 3 and at x equals 1. Now what we should do with these is we should take them and plug them back into our original equation to make sure that they work. So if I plug in the 3, I would get 3 plus 3 over 3 equals 4. And 3 over 3 is 1, and 3 plus 1 is equal to 4, so that one works. And if I plug in the 1, I would get 1 plus 3 over 1 equals 4. Well, 3 over 1 is 3, and 3 plus 1 is 4, so that one also works. We're going to look at another example in here, and we're going to solve the equation x plus 1 over x minus 4 equals 0. Now, as far as our fraction in there, we're dividing by the x minus 4. So in order to get rid of that fraction, I'm going to take my entire equation and multiply by x minus 4. Now when I take the x minus 4 and multiply by the x, I'm going to have to do some distributive property. So x times x is x squared, and x times the negative 4 is negative 4x. When I take the x minus 4 times the 1 over x minus 4, the times x minus 4 will cancel out with the divided by x minus 4, and I'll just get plus 1. Now on the right hand side, when we take 0 times x minus 4, 0 times anything is just 0. So we get the equation x squared minus 4x plus 1 equals 0. Now we could try to factor this one out, but it's not going to work. So we're going to have to do the quadratic formula. So if I start plugging my numbers into the quadratic formula, I'll get 4 plus or minus the square root of negative 4 squared minus 4 times 1 all over 2 times 1 would just be 2. Now underneath the radical, we're going to end up getting 12, and then we can simplify down that square root of 12 a little bit. So this will end up being 4 plus or minus 2 root 3 over 2. And we can actually simplify this down a little bit further. Both of these terms are being divided by the 2, so 4 divided by 2 is 2. And when I take the 2 root 3 divided by 2, the 2's are going to cancel each other out, so it'll be 2 plus or minus root 3. Now we can get decimal approximations here. If we take 2 plus the square root of 3, we're going to get about 3.73. And if I take 2 minus the square root of 3, then we'll get about 0.27. Now it might be tough to plug these values into our original equation to make sure that they work, so we can check our answers graphically as well. So I've got my equation typed into my calculator. I didn't put the equal 0 on there, I've just got the x plus 1 over x minus 4. When I hit graph, we're going to end up with a picture that looks something like this. Now we're looking for where our equation was equal to 0, meaning we're going to look for the x-intercepts of our graph. So if I go second trace, the x-intercepts are the 0, so I'm going to pick option number 2, and I'm going to start with the 0 on the left-hand side. So I'm going to do my left bound and my right bound point there. So we get about 0.27, like we had mentioned, and then if I do my other x-intercept as well, doing the left bound and the right bound point, we get about 3.73. That's going to be it for this video. Thanks for watching.